Good day, Ma'am Dison. And for today's video, I am going to have an oral performance in Lesson 3 and 4 assignment. The three types of atomic model are Joseph John Thomson, Rutherford, and Bohr. Joseph John Thomson, who discovered the electrons in 1897, proposed the pan-folding model of the atom in 1904 before the discovery of atomic nucleus in order to include the electron in the atomic model. In Thomson's model, the atom is composed of electrons, which Thomson still called corpuscle. G.J. Stoney had proposed that atoms of electricity be called electrons in 1894. Surrounded by a soap of positive charge to balance the electrons' negative charge, like negatively charged palms surrounded by positively charged pudding. The electrons as we know them today were thought to be positioned throughout the atom is rotating rings. In this model, the atom was also sometimes described to have a cloud of positive charge. In this model, Thomson abandoned his earlier nebular atom hypothesis, in which the atom was composed of immaterial vortices. Now at least part of the atom was to be composed of Thomson's particulate negative corpuscles, although the rest of the positively charged part of the atom remained somewhat nebulous and ill-defined. The 1904 Thomson's model was disproved by the 1909 gold foil experiment performed by Hans Geiger and Ernest Marsden. This gold foil experiment was interpreted by Ernest Rutherford in 1911 to suggest that there is a very small nucleus of the atom that can contain a very high positive charge. In the case of gold, enough to balance the collective negative charge of about 100 electrons. His conclusion led him to propose the Rutherford model of the atom. The Rutherford model is a model of the atom named after Ernest Rutherford. Rutherford directed the famous Ginger-Marsden experiment in 1909, which suggested, according to Rutherford's 1911 analysis, that Thomson's so-called palm pudding model of the atom was incorrect. Rutherford's new model for the atom, based on the experiment results, contained that new features of a relative high central charge concentrated into a very small volume in comparison to the rest of the atom. The central volume also contained the bulk of the atom's mass. This region would later be named the nucleus. In 1911, Rutherford designed an experiment to further explore atomic structure using the alpha particles emitted by a radioactive element. Following his direction, Geiger and Marsden shot alpha particles with large kinetic energies toward a tin full of gold. Measuring the pattern of scattered particles was expected to provide information about the distribution of charge within the atom. Under the prevailing palm pudding model, the alpha particles should have been reflected by at most a few degrees. However, the actual result surprised Rutherford. Although many of the alpha particles did pass through as expected, many others were deflected at small angles, while others were reflected back to the alpha source. Niels Bohr model proposed the Bohr model of atom in 1915 because the Bohr model is a modification of the earlier Rutherford model. Some people call Bohr's model the Rutherford-Bohr model. The modern model of the atom is based on quantum mechanics. The Bohr model contains some errors, but it is important because it describes most of the acceptable features of atomic theory without all of the high-level math of the modern vision. Unlike earlier models, the Bohr model explained the Rydberg formula of the spectral emission lines of atomic hydrogen. The Bohr model is a planetary model in which negatively charged electrons orbit a small positively charged nucleus similar to the planets orbiting the Sun, except the orbits are not planar. The gravitational force of the solar system is mathematically akin to the Coulomb electrical force between the positively charged nucleus and the negatively charged electrons. The difference between physical and chemical change is when a substance undergoes a physical change, its composition remains the same despite its molecules being rearranged. While when a substance undergoes a physical change, its molecular composition is changed entirely. These chemical changes involve the formation of new substances. Physical change is a temporary change, while a chemical change is a permanent change. A physical change involves a very little to no absorption of energy, while during a chemical reaction, absorption and evolution of energy take place. Generally, physical changes do not involve the production of energy, which can be in a form of heat, light, sound, etc. In physical change, no new substance is formed, while a chemical change always accompanied by one or more new substances. The example of chemical changes will be grilling, burning, roasting, cooking, and rotting. The example of physical changes be crumbling, boiling, freezing, melting, shading. Chemical properties are properties that can be observed or measured with a substance undergoes chemical change, while physical properties are properties that can be observed without bringing a chemical change. The chemical properties are connected to chemical bonds of a substance, while physical properties do not have such relationship. A chemical reaction needs to be conducted to show the property, while physical property, no chemical reaction is needed here. The example of chemical property include reactivity between chemicals, toxicity, radioactivity, flammability, and heat of combustion. And the example of chemicals, volumes, mass, shape, solubility, and color.